Now the question, please.
I just would like to know, very thank you for your wonderful talk. You mentioned some research work about some metrics like oscillation in systems that are learning and in this convolutional system network. Do you have some evidence with a detection of, I don't know, a picture or sounds, or I don't know? So, you know, there's a huge number of researchers now that are working on this explainability and transparency of this kind of system. So, what kind of cues or measure you have in this system that are relevant to know more about the learning of the system? Because you spoke about this a little bit.
Well, as Stanislas said this morning already, we can record from many nodes in these networks the activity, and with high temporal and spatial resolution. And then we see, by using correlation analysis, how these nodes interact with one another, and we see the complex dynamics that emerges from such recurrently coupled networks. And what we see, and this is not existing in artificial systems, is that all the connections, they are endowed with adaptive synapses, the so-called Hebbian synapses, that increase or decrease their gain as a function of the temporal correlation of the activity of the two connected partners. We think that learning is occurring in that way. That's not your question.
But my question was about artificial intelligence, not...
Well, as far as I know, there are no implementations of Hebbian synapses in artificial systems. You have to compute changes in coupling strength, either through a backpropagation algorithm, or there are now biomorphic chips that can do something similar using memristors. But this is all very, very fundamental, very simple yet.
Okay, thank you. I have 4 names, Armin, then Marcus, then Antonio and Gilles. Any other else? No. Armin, please.
Okay, thank you. Well, thank you for the great talk. Of course, we have a long, long way to go from the natural science point of view. But there are some overlaps already with artificial systems. I think you would agree that dynamical systems theory, for instance, is a point where we would meet. And so I would like to ask, just as an example, one technical question. I think it is clear that network topology very much decides on the dynamical possibilities of a system. So what lessons can we learn so far that could be transferred into the design theory for artificial systems?
Well, what we see is that these natural networks, the reciprocally coupled networks, they operate very close to criticality. And this is the dynamic range where they can very quickly go into local minima, but it has to be controlled very, very carefully. And nature invests a lot of mechanisms in order to keep the networks in this very narrow dynamic range, controlling the runaway dynamics so they don't get epileptic, and on the other side, preventing them from falling dead. Nature has solved this problem, apparently with a hierarchy of supervising systems. I think technical systems don't have that problem yet because they don't evolve these very complex dynamics yet.
True. Yeah, thank you.
Okay, thank you. Marcus, please.
Well, yeah, thank you very much. I agree entirely with the perspective. I would like to know how much top-down causation, if this is a notion that makes sense to you. Many emergence theorists right now in physics, I just wrote a paper with George Ellis, for instance. He's a cosmologist. He works on top-down causation on scales of the universe and so forth, and has demonstrated, by the way, remarkably, that this is, the solution to the measurement problem in quantum mechanics. Measurement has always taken place already at the beginning of the universe because there weren't isolated quanta. There was already a context with top-down causation. So apparently causal chains, even in the non-human and non-biological universe, tend to run top-down. So I wonder how much top-down causation you think we could find from what you call the spiritual dimension to, say, individual brains. So do you think that we can find, I mean, there must be causal relations, obviously, right? Someone learns a language, therefore certain connections are enhanced and so forth. So obviously that would be a kind of top-down causation, or do you think that this goes one, just bottom up the process?
We would say there is no mental top-down causation in the sense that some immaterial construct existing somewhere would influence neuronal processes so that they do what this immaterial entity wants them to do. But as you talk to me, of course, you produce a sort of top-down causation of my responses. Yeah. But we physically interact with each other. So yeah, there is a lot of top-down control in natural systems. There are about 10 times more top-down connections than bottom-up connections. And we are just at the very beginning of understanding what they actually do.
Mm-hmm.
Now, please, Antonio, please, very brief, if you can.
Thank you very, very much, Wolf, for remarkable. I would say, could we add to your list of the natural networks the role that nature plays with recycling? When you have a disabled brain, you can replace sometimes quite easily part of the brain, even half of the brain, as we have done. We have seen in the case of Nico that you know about a complete right hemispherectomy. And then recycling is not at all mentioned in the artificial intelligence, I think.
Well, these very distributed systems, the reciprocally coupled systems that have display nonlinear dynamics, they have interesting properties with respect to robustness and resilience. If you take elements out, they show graceful degradation, they don't just fall dead, and they have properties of self-healing, of self-repair. And so this makes much of a robustness of these very, very complex systems. There's an interesting theory. In former times, one tried to produce resilience and robustness by redundancy, by doubling, tripling the important structures. A more modern strategy that is used in most of the airplanes is to render the control systems more complex. And if one element drops out, the rest will sort of elastically compensate for it. So complexity may be a resilience strategy.
Yeah, my question is about the importance of. Yeah. My question is about the importance of personal experience. There is this thought experiment in philosophy of mind that if you take someone and you copy her atom by atom, then the copy has the same memory as the original one, the original person. And this is partly what we do when we induce memories in someone, when we create fake memories in someone. And it's also something we partially do when we read a book where we can benefit from someone else's personal experience, even if there is something which is lost in translation. So could not we imagine that we can create, without a personal experience, an artificial being that would have had a personal experience?
Yeah, you would somehow have to be able to instruct the knowledge, so the internal model of the world, into this artificial thing. Now, in our brains, this model of the world resides in part in the functional architecture of the wiring. And this is the genetically translated knowledge that we have acquired during evolution, because evolution is a cognitive process. And then there is the completion of this knowledge through all the genetic experience and lifelong learning. Yeah, if you could make a one-to-one copy of myself by having access to all the synaptic weights of the 10 to the 14th connections in my brain, including putting a little bit of fur on it and so, yeah, I would be indistinguishable. But I think this is just a nice thought experiment. It cannot be done.
Pierre.
Yeah, my question is about your second phase transition and the way those priors are being built up. So my question is twofold. Are those priors the result of actual education of the child, or are they transmitted from all the previous history of human beings? And second, is there possible to have an evidence, experimental evidence, describing those priors in a given brain?
That would require a Kaspar-Hauser experiment, of course, to see how much of it is genetically installed, unless there's coevolution between our brains and cultural evolution, which I'm not a specialist in. I would think that most of it is learned after birth. We educate our children as a function of these priors, assigning things like free will to them, telling them if you don't do this, or if you do this, it will. This, of course, suggests to them that there is something like freedom, and they learn this concept. And so I think we have learned about those immaterial realities sitting around the fireplace and realizing that there are greedy people and generous people, and then we find words for greediness and generosity, all realities that are immaterial but very, very mighty, because they make us erect cathedrals. I mean, the content of a belief is very mighty in controlling our behavior. And I think this is cultural tradition, and we are all embedded in it, and we pass it on to our children over and over again. We can't do the experiment because we cannot deliberately deprive our children of these benefits.
Thank you. The last one, Maggie, please.
Thank you. It's always possible when you're comparing two things to elasticate the differences between them or to minimize them. Now, I think you have elasticated them, and I completely disagree with your characterization from the social sciences of such things as the self, self-awareness, reflexivity, concerns, things that I think are vital. But I don't want to go into your account or implicit account of these here. Rather to pursue the thought, can there not be two different ways of arriving at the same destination? So you give one example about 1/3 of the way through, about a form of AI that was confronted with two solutions to two questions and was incapable of resolving whether these were contradictory or complementary, right? Well, I think there's a very simple way with the appropriate equipment for an AI entity to do this, and that would be to print out the two propositions that were the conclusions and, as they say in school, show the workings. Now, what is there about an AI robot which is incapable of doing the basic computation that's involved in that, which is very simple indeed, and coming up logically, and if need be, one could upload a simple logic program, therefore could come up with the conclusion that these two propositions are either complementary or contradictory, and then know what to do from there, or have hypotheses about what to do from there. Now that narrows the gap considerably, because we don't have to write out, type out, print out, and show our workings for how we reached a decision about voting, or is somebody guilty or innocent, if you are a member of a jury, and many, many more examples. But the two things, two different ways of working, are producing the same kind of result, and not just in terms of Wittgenstein's family resemblances, the same natural kind of result. This conclusion follows from these premises.
I fully agree. Implementation doesn't really matter. Airplanes don't flap with their wings, and they fly faster than birds. As I said, one could probably implement everything that biological evolution has brought forth if we understood enough about our brains, and so we could perhaps make a robot that has the cognitive abilities that we have. That would be the first phase transition. I doubt, though, that one can implement also all the knowledge required in order to achieve the second phase transition by harvesting the knowledge that we have about social realities, social norms, belief systems. I wouldn't know how to implement them into a robot unless educating them in our societies, because don't forget there is also something, and this was relevant for the teaching with robots. We know very well that at least human children do require the emotional binding to their mentors in order to acquire certain skills. You simply cannot algorithmically instruct them to do that. At least it's not possible. In the moment, there is no model to do that. But I think I'm not a specialist in your domain, and I anticipated having trouble with it. That's all I can say.
Thank you, Wolf. I think we can get into depth in the general discussion, maybe at the end of the session.